Good morning, students. Today we are going to discuss London's second equation. Before that, the London's first equation is djs by dt is equal to ns e square e by m. This is London's first equation, right? So in this case, if e vector is 0, this becomes 0, means djs by dt is 0, means gs vector is constant. Rate of change of gs is 0, means gs is constant. Gs is constant means it leads towards persistent current. So again I repeat the same thing. What is persistent current? If E vector is 0, electric field vector is 0, then djs by dt is 0, means gs is constant, which gives us that resistance is 0, because no collision of electrons and current flow at that time, right? So this current is called superconducting current or persistent current, right? Now for deriving London second equation, we just consider again the current density, that is Jn, for normal current, where n is the current, where Jn is the current density for normal current. Let us consider London's first equation again. So what is London's first equation? djs by dt is equal to ns e square e by m. Now taking curl to both sides, del cross djs by dt is equal to del cross of ns e square e vector by m. Take d by dt outside here in left hand side, rest of the term becomes del vector cross gs vector is equal to, here take ns e square by m outside, rest of the term become del vector cross e vector, right? So in the next step, we know that this is Maxwell's third equation. We know that Maxwell's third equation is del cross E vector is equal to minus curly B by curly T. Now put this value of del cross E here. Instead of del cross E, write minus curly B by curly T in the next equation. This means d by dt of del cross Js is equal to ns E square by m into minus curly B by curly T. I just put the value of del cross E here in this equation, right? That is minus curly B by curly T. Okay, after putting the value, what you have to do, and this becomes del cross Js, and d by dt of del cross Js is minus ns E square. We just take curly by curly T outside, the rest of the term minus ns E square B vector by m, and here d by dt, right? Now integrating both sides. After integrating, the term become del vector cross gs vector is equal to minus ns E square B vector by m. Take it as second equation, and this is called London's second equation, right? This is called London's second equation. Now our aim is to find penetration depth or penetration depth of the field. So what is penetration depth? It is the distance into the superconductor at which magnetic field can penetrate through it, which also varies with temperature, right? So it is called penetration depth. Again we consider Maxwell's fourth equation. Let us consider for superconductors, Maxwell fourth equation is del cross H is equal to J plus curly D by curly T, right? I just multiply both sides by mu naught. Multiply mu naught here, multiply by mu naught here on both sides. Mu naught H is B vector, right? And right hand side mu naught is here, right? So B is equal to mu naught H, B is equal to mu naught H. So it becomes del cross B is equal to mu naught into Js vector plus curly ds vector by curly T. So fields are varying very rapidly. Here fields are varying very rapidly with time. Therefore displacement current is negligible with respect to Js vector. Here displacement current is negligible with respect to Js vector. Therefore d vector is equal to 0. After putting the value of d vector is equal to 0, rest of the term becomes del vector cross b vector is equal to mu naught Js vector. Now taking curl of above equation, del cross B is equal to del cross of mu naught Js vector. Now curl of a vector is first third dot product, del dot B, take del outside, rest of the term is B outside, and del dot del. Del dot del is del square into B vector is equal to take mu naught constant outside, mu naught is equal to del cross Js, right? Again, the term, we know that del cross Js is, according to London's second equation, del cross Js is minus ns e square b by m. We just put the value of London's second equation here. Del cross Js is equal to minus ns e square b vector by m from equation 2, right? So del vector into del vector dot b vector is equal to minus del square b is equal to mu naught into minus ns e square b by m, right? Now, but del dot b is equal to 0. This is Maxwell's second equation, but del vector dot b vector is 0. Maxwell's second equation. Put this value here. This term becomes 0. Rest of the term is minus del square b is equal to mu naught into this thing, right? Minus del square b is equal to minus mu naught e square ns b by m. Cancel the negative term on the board from both sides. Del square b vector is equal to mu naught e square ns b vector by m, right? Del square b vector is equal to b vector by lambda square. This equation may be written in this form, where del lambda is equal to root m over mu naught e square ns. This thing, where lambda is equal to root m over mu naught ns e square, and this is called London's penetration depth, where lambda is called London's penetration depth, right? So our next topic is BCS theory. This theory was proposed by American physicists Bardeen, Cooper and Schrieffer. This is the name of three scientists who had developed this theory, and after their name this theory is named as BCS theory, and this theory was developed in year 1957. They developed quantum theory of superconductivity, right? According to BCS theory, superconductivity is due to interactive interaction between electrons at low temperature. Due to this interaction, electrons moves in pair called Cooper pairs. According to Coulomb's law, as we already know that opposite charges attract each other, means positive charge attract to the negative charge, opposite charges attract each other. Whereas in case of BCS theory, this theory is contradictory to that. BCS theory is opposite to that. Here two electrons attract, or we can say two electrons interact with each other, and this pair of electrons is called Cooper pairs. The two electrons move coherently through lattice so that they do not collide with the lattice ions. Due to this, resistance becomes zero and material becomes superconductor, right? So we can say the two principal features of BCS theory are: first feature is that electron form pairs called Cooper pairs which propagate through the lattice, and second second principal feature of BCS theory is that this propagation of electron, this propagation of we can say phonon is without resistance, because the electrons move in resonance with phonons, right? Now how this electron-electron interaction takes place: unless in Coulomb's theory there is a repulsive interaction between two electrons. We know that same charges repel each other, whereas opposite charges attract each other. But in this case, same charges interact or attract with each other. So Coulomb's theory is opposite to that. According to BCS theory, the first electron moves due to Coulomb interaction in lattice, which consists of positively charged atoms. The positively charged atoms will trap the first electron. Now second electron, when passed through the same lattice, then due to large density of positive atoms cloud, they will attract another electron in equilibrium condition. A balance between attraction and repulsion is established, and two electrons combined to form a Cooper pair. The two electrons tends to move in the same direction. These pair of electrons will change phonons through lattice ions. So this theory is based on electron-electron interaction. Okay, understood? Thank you very much.